So, hi everyone. Hopefully you can see me over this podium here, and hopefully you can hear me. My name is Claire Byrne, or Claire Dickson, as my married name is. I haven't changed all my names yet, so whatever you want to call me. I'm a senior security data engineer at Elastic, the people who make Elasticsearch. And I'm a bit of a nerd when it comes to security and threat intelligence. So today we're going to talk about something sweet. Honeypots. Not the Winnie the Pooh kind, the kind that attracts more than just cute bears, the kind that catches hackers. We're going to explore how you can use AI and a bit of clever trickery to build realistic digital observatories that attackers can't resist. So first of all, what exactly is a honeypot? At its core, a honeypot is a digital decoy. It's a system that looks like a vulnerable, high-value target. So this could be an exposed database, or a seemingly insecure login page, or even an entire application. But its real purpose isn't to serve customers or to provide functionality. It's there to observe attackers and to help gather threat intelligence so that we can better defend our systems against real-life threats. Honeypots are designed to draw attackers in, let them think they found something juicy and valuable, and then log everything they do when they don't know they're being observed. So what's this project that I'm going to talk to you about today then? This is a project that we did as part of a hack week in Elastic, and it was a proof of concept that was done just for fun, effectively over 3 days in early 2025, and the honeypot has been running ever since, open to the public internet. You might be wondering why I feel like I'm qualified to stand up here and ramble about honeypots to you. And that's because it's been a subject I've been really passionate about since I graduated from Queen's with my cybersecurity master's and my thesis on applied honeypots under my belt. Back then in 2016, when we didn't even have colour TV yet, we had to create honey nets and the data for them in a really painstaking and manual way, designing, implementing, deploying each layer, doing all the JSON ourselves. But now, AI might actually be able to do something really useful and help us out. And that's what excited me about collaborating with my colleague Miguel Garzon on this Hack Week project to find what we find on the public internet. So before we dive into the juicy stuff, let's have a talk about ethics. Honeypots can be incredibly powerful, but they also come with responsibilities, obviously. So first and foremost, in a honeypot, we never use real customer data or real user data. No real customers, no real accounts, nothing. Second, we don't retaliate or engage with attackers. Our goal is to observe from a distance, like David Attenborough, not to entrap or provoke. We're researchers, we're not vigilantes. We want to learn from attackers and not become part of the problem. So yeah, basically think of it like building a camera and not a trap. So you might also be thinking, or maybe you're not, I don't know, but what's the difference between a honeypot and a phishing attack, where users are made to think they're using a real software? Well, in a phishing attack, the information is usually extracted under duress or urgency, like think, oh, you've won a prize, but this link expires in 30 seconds. Honeypots don't do this. They don't provide duress, and they don't take action against the users of the system. And that means there's a lot of pressure to design a system that looks real, and feels real, and responds in a way that seems real. And that's where this project comes in. So, why? Why go to all this effort? Because honeypots give us what traditional defenses often can't, and that's clarity. In a normal environment, you're flooded with alerts and noise and false positives, and you can't really separate a legitimate user error from a malicious actor. With a honeypot, there are no legitimate users, so any activity is inherently suspicious, and that's what fascinates me about it. It means it's pure signal. So I'm just going to ramble a little bit more before I show you any data. By their nature, most honeypots are facades and don't usually go too deep. So we're probably observing attackers in the reconnaissance phase of their attack, but it really depends how invested you are and how deeply you want to do the research. So when we talk about honeypots, there are two main categories: low interaction and high interaction. Low interaction, they're the quick and easy ones. They're mainly based on one service. They simulate just enough of a service to look enticing. So think like a little bit of fake SSH, a little bit of fake FTP, or maybe an Elasticsearch instance. They're mainly for catching scans and bots and just seeing what's out there. No real like intelligence or persistence or like deep threat research. But with high interaction honeypots, these are like the full stage play, not just the facade. They simulate entire systems, and attackers believe they've hit the jackpot, which means they stay longer and reveal more. But the thing about these is they are very hard to maintain, and you need lots of guardrails to make sure your system isn't actually hacked. And that nearly happened during my master's project. Ask me about that at the after party. So yeah, both are useful, but the honeypot I'm going to talk to you about today is a low to medium interaction with a view to becoming high interaction. So basically we were hoping to see who finds these systems on the public internet. Are they bots? Are they humans? How deeply do these people interact? And how far will they go to extract data? And does realism change anything? So let's get into the technical details then. We created what looks like a legitimate Elasticsearch cluster available at the classic Elasticsearch port 9200. It was made to look like a misconfigured Elasticsearch instance for a banking website. So obviously a known target for attackers. Here's the twist though. There's no actual data behind it, and it's not a real Elasticsearch node at all. It's a Python app behind the scenes. So the backend's a Python web app based on AIO HTTP, that's really hard to say, that talks to a large language model that provides all the responses. So even if an attacker runs a script that would normally compromise an Elasticsearch instance, it can't. It's Python. It doesn't understand. So the LLM will make up customer data, transaction logs, whatever the attacker is looking for, all on the fly, and respond to the request that the attacker makes in a legitimate looking way. So the architecture was, just as I've said, an I'm not going to say that, a Python app which takes incoming web requests, and we basically instructed the LLM behind the scenes that you're a vulnerable Elasticsearch instance, please act like one. The whole thing was hosted on a cloud provider, which I probably shouldn't name in case I get into trouble. And to make things efficient, we also used a little SQLite database. That works as a cache because a lot of the interactions we were seeing were from bots. So it means that anytime an attacker sends in the same query twice, as is going to happen with bots, they're going to send a load of the same requests. We don't have to keep bothering the LLM with that, and it doesn't clog it up or like take ages to respond, which could be a tell for a honeypot. Instead, we hash the same requests, stick them in a table, and serve it up instantly if it ever comes up again. So for logging then, every request and every response gets written out to a log file. So from there, we use the ancient Elasticsearch tech of FileBeat to ship those logs over to an actual real Elastic Cloud cluster. That gives us a clean, centralized place to sort of analyze all attacker behavior and crunch the numbers on the data. So we can see what queries they tried, what tools they used, how long they stuck around, and just what they did. And we can build dashboards out of that and get pretty graphs, which is what I'm all about. So, to make the data that we were returning to attackers believable, we trained the LLM to respond as if it were a compromised Elasticsearch instance. We used Azure OpenAI as the API and gave it a very detailed, very long prompt that included some valid customer accounts and passwords and valid indices that they could query on the Elasticsearch cluster, so like tables in a SQL database, if you're not familiar. We also set the LLM temperature to 0 so that it generated responses that were predictable and deterministic, and giving it minimal creative license because it could end really badly if we didn't. So basically, if an attacker sent a real Elasticsearch query, it would respond in a way that looked real. And that's the point. So here's one of the tells that probably one of the tells that it was a honeypot that we can work on. But this is an example of the fixed response we gave it for when an attacker tries to run a cat query on our instance. So for those of you who aren't too familiar with Elasticsearch, a cat query normally returns information about the indices on a cluster, although you can tailor it to return more specific information in the parameter path. So can anyone tell me what might have been a tell that, that this was a honeypot? What data is invalid here? Yep. And I literally only noticed this when I was making these slides. So yeah, lesson learned. Also, it returned the exact same data every time. So that's another tell for a honeypot. So don't do that, basically. So here's a visualization of how much that cat endpoint was queried. 615 times at the time of writing this presentation. And obviously, given more time, I would have loved to, flesh that out a bit and like add different responses for the different cat queries. But as we did this in 3 days, I think this is quite good. Okay, so the bit you're all waiting for. What did we actually see? So within hours of going live, minutes even, we were seeing scans against the system. And as of the time of writing this, we've seen nearly 11,000 interactions against the honeypot, most of which have been bots, but we've definitely had a few humans poking around too. We also had Census, who are basically a good authority for internet intelligence insights, scan us several times, and I'll show you what happened with that later. But let's just say, I think we came across quite convincingly. So, some of the data then. So I'll just talk through this then. So the part on the left, is that left? Yeah. So we have the body of the request that the attackers sent, base64 encoded on the left there. And on this side, we have the base64 decoded version of that. So the interesting bits are the first one, which is, that's just a normal Elasticsearch query. So we would expect that if we were seeing maybe humans poking around at this. That's just a query that matches everything in the cluster and returns it. The next one of note is probably the third one down. So they're basically trying to execute a command within a script within our Elasticsearch instance, and that would probably have worked if it was a real Elasticsearch instance, but it wasn't. So I'm actually interested to see what that returned, because I actually can't remember what the LLM will return in that case, so interesting. And then the other interesting one was, you can't really see that. There is one up from the bottom, and it just basically says that a guy called George was poking around on a Windows laptop, giving us his hardware serial number as well, so nice. Thanks, George. I don't know if you can see this. Okay, you can't really see this. I'll talk through it. This is another bit of data where we were basically tracking the authorization that attackers tried to use with this. So again, on that side is the base64 encoded version. On this side is the decoded version. So you can see that attackers are trying, general bot things like 123, 123 admin. There's some NTLM handshakes, which are a Windows authentication thing. Probably George again, to be honest. The other interesting one is the username Elastic and the password Northbank Elastic. This was a username and password combo that we were using to test. We were actually using this for testing the LLM. However, this came up a lot more than the number of tests that we did. So I'm wondering if the LLM spat it out as a possible password, given the fact that we tested on this so much, which is really fascinating and something for me to look into. And then the next interesting one here is the next one down, which is username Elastic and password Changme. Not change me, Changme. So this tells me that maybe somebody plugged this into an automated tool and typoed it, and then sent a ton of requests to our instance, which again, interesting. Don't quite know what to make of it, but interesting. And then the next thing that interested me was the path that attackers used in the query. So with Elasticsearch, you essentially send a curl request. So you send it to a URL with a path. So this was the last part of the path part that I said part a lot there, that the attackers used. All of these are genuine looking-ish Elasticsearch things, apart from the AAB and the fabicon.ico, which indicates bots. But I want to zoom in on the search path here, because what are people searching for here? That's the interesting bit. So, again, I don't know if you can see that very well, but we got some very interesting stuff in the search query. And a lot of scripts coming from certain countries. And yeah, the one on the top right here is definitely an attempt at compromise, and I'd pass this along to our threat research team to see what they make of it. And yeah, this one on the top, the far corner, was done a lot, multiple times a week. So again, interesting, and I took the liberty of translating it. Again, I don't know if you can see that, but very interesting. Just, yeah. And then, yeah, so this is the dashboards I was getting very excited about. Again, I don't think you can see this, apologies. But we were most scanned by the USA, which is really interesting, and with a region of New Jersey. And yeah, you can sort of see the user agents that people used, or maybe you can't. Come see me afterwards if you're interested in this. And you can see also that we got scanned a lot by Census, Amazon, and a lot of Chinese companies. Again, interesting. So I mentioned Census. So this was our report on Census. And as you can see, it lists us as an Elasticsearch cluster with ports 9200 and 9300 open, which is correct. We asked the LLM specifically to act as an Elasticsearch cluster with these ports open. The other interesting bit is that it correctly or incorrectly identified it as an Elasticsearch 8.5 cluster, which is exactly the version that we asked it to emulate. So that's a major win in my books. We managed to trick one of the biggest scanning systems on the internet. Yeah. So takeaways then. Attackers move really, really fast. You'll get scanned almost immediately, obviously, if you put anything on the internet. Secondly, realism does matter. As we saw with the cat endpoint, people kind of abandoned that. But yeah, if a honeypot does look valuable, attackers will try things. And third, LLMs are incredibly effective at crafting believable fake data. They scale deception and they do it really, really well. So yeah, whenever I did my cybersecurity masters, we had to spend hours making the data, but now we have AI tools at our disposal, and that can help us out, and we can iterate a lot more quickly. So looking ahead, this technique has huge potential. Imagine honeypots that adapt in real time based on the attacker's input, or LLMs that simulate internal enterprise networks, or changing error messages, or even fake SOC activity. This project was a proof of concept that we cobbled together in about 3 days. Imagine what else we can do with this, given more time. I think there's a lot of research to be done here, and a lot more fun to be had in a safe and legal manner. So thanks so much for listening. If you're interested in collaborating, building honeypot systems, or just chatting, let's connect after this, or at the after party. And remember, best way to understand an adversary is to invite them in with a little bit of honey.